Ooh, base of a solid is the region enclosed by a circle centered at the origin with a radius of 5 inches. Find the volume of the solid if all cross sections perpendicular to the x-axis are squares. Okay, so we have a circle on a surface, and then out of that circle, squares are popping up. So let's think. The dimensions of each of these squares is kind of whatever this length is. But if I just think of one piece of that length, that's just the y value there. So let's think. It's a circle centered at the origin. The radius is 5. So x squared plus y squared equals 5 squared, because circle is distance. So x squared plus y squared equals 5 squared. If I use that, and I say, okay, that means y equals 25 minus x squared. Don't you dare write that as 25 minus x, by the way. Technically, it's plus or minus, I know. This is also y, right? So that whole distance is 2y. So if I look at this square, this distance here is 2y. Another way of saying that, that's 2 square root 25 minus x squared. Well, that's this distance also. So that means that the side length, this is set up the same idea except instead of radius I write side, is 2 square root of 25 minus x squared. The area is that squared, so 425 minus x squared. And then the volume is going to be, I got to add them all up. And they go from negative 5 to positive 5. To positive 5, 425 minus x squared dx. Now you should be able to do that. And I'll have the answer magically appear. And I got 2,000 thirds. Notice, there is no pi because we are not rotating. So there is no pi. Base of a solid centered at the origin with a radius is a circle centered at the origin with a radius of 3 inches. Find the volume. So this is the same question basically. It's just a different shape. Well, it's a circle. So x squared plus y squared equals 3 squared. Y is going to be 9 minus x squared, square rooted. That's like this distance here. Okay, so we have an equilateral triangle. This distance here is the square root of 9 minus x squared. This distance here, since we're equilateral, is 2 square roots of 9 minus x squared. Can you catch that? Do you know that? Do you know why that is? I hope so. It's because the bottom part is 2 square roots, so each of the diagonal parts is 2 square roots. Now you can either use your knowledge of trig or the Pythagorean theorem. You'll figure out that that height is the square root of 9 minus x squared with a square root of 3 over 2. Again, you can either use your knowledge of trig, hint, that's a special kind of triangle, or you can use the Pythagorean theorem, this squared minus this squared, and square root it, because 4 minus 1 is 3. And then, okay, so I now have the base and the height. The base is 2 square root 9 minus x squared. The height is that. So the area is 2 square root 9 minus x squared times square root of 3, square root 9 minus x squared over 2. I can get rid of those 2's. And I can get rid of those square roots. So that means that the area is actually square root of 3 times 9 minus x squared. Which means that the volume is the integral from negative 3 to 3, square root of 3, 9 minus x squared dx. Which you should be able to do. You should do it right now. And through my magic, I got 36 square root 3. Notice again, no pi's, no circles, no pi's. Ooh, a mathematician has a paperweight. The base is the region between the x-axis and one arc of the 2 sine x. Cross-section perpendicular. Okay, so we have semicircles popping out. This whole distance here is 2 sine x. So we have a semicircle. This whole distance is 2 sine x. Doesn't that mean that that's just sine x? So the radius is sine x? So the area is pi r squared. I left an awkward pause there because I was envisioning you yelling at me right now because I didn't do divided by 2 because it's a semicircle. If you didn't yell at me, you weren't thinking. Shame, shame. And then the volume, I integrate from 0 to pi sine squared over 2 dx. Now, we don't know whose derivative is the sine. So you have two choices. Choice number 1 is to use technology to figure out the answer to this. And if you don't know how, we should talk. Choice number 2, ignore that random mark, is to use the power reducing identity, which you don't have to know, but for funsies, I'm going to show it to you. Sine squared plus cosine squared is 1. That's an identity I know. Doesn't that mean that sine squared, is this what I want? Yes, is 1 minus cosine squared? And then, that's actually not what I want. I lied. What you want, I'll get there eventually, is the cosine of 2x, which I could build for you. Cosine of 2x. It's cosine, it comes from cosine of a sum. It comes from some other things. So it's cosine, cosine minus sine, sine, also known as 1 minus 2 sine squared, because of that sine squared plus cosine squared thing. So I did use it. Solve for sine squared. Well, solve for sine. Add that, subtract that. 1 minus cosine 2x over 2. You could find the antiderivative of that. Again, you don't need to. You could just use a calculator. And when I used a magical calculating device, I got pi squared over 4 as my answer. And if you did this exactly, I hope you get to the same place.